Hello and welcome to yet another calculus video of Cornerstones of Math. The calculus problem that we will be dealing with is this. An object is moving on a straight line and its velocity vt in the time interval t being greater than or equal to 0 and less than or equal to 3 is given as below. So we have this graph, velocity versus time, for t being greater than or equal to 1 and less than 2, and t being greater than or equal to 2 and less than or equal to 3, the velocity vt is given as a straight line in each interval. So these two segments are straight lines. For t greater than or equal to 0 and less than 1, vt is given as pt cubed plus qt squared plus rt. So this part of the graph is a cubic function, pt cubed plus qt squared plus rt. The velocity vt is differentiable on the interval t greater than 0 and less than 3, except at t equals 2. So this point, t equals 2, is not differentiable. Moreover, the acceleration at of the object is maximum at t equals 1/2. So this point, t equals 1/2, is where the acceleration at is maximum. Find the values of p, q, and r and plot the acceleration at of the object on the interval t greater than 0 and less than 3. Alright, we have three unknown coefficients p, q, and r, which means that we need three equations, so we have to utilize three conditions given in the problem. And we will start with this differentiable condition. First, before we differentiate anything, since vt is differentiable at t equals 1, it must be continuous at t equals 1. FYI, the converse is not always true. So the function on the left side is this cubic function, so when t approaches 1, the value of the function approaches p plus q plus r. This value must be equal to the value given in the graph, which is 1. So we have the first equation. Now let's move on to the fact that since the function is differentiable at t equals 1, the derivative v'1 must exist. For the function on the left, v'(t) equals 3pt squared plus 2qt plus r. Since vt is differentiable at t equals 1, its slope at t equals 1 must be 0, which is the slope approaching from the right. So we have 3p plus 2q plus r equals 0. So we have our second equation. Finally, we use the given acceleration condition, that it is maximum at t equals 1/2. The acceleration at is simply the derivative of vt with respect to time. So at t between 0 and 1, the acceleration at is given by 3pt squared plus 2qt plus r. And since this acceleration has its maximum at t equals 1/2, the derivative of at t equals 1/2 must be 0. FYI, this derivative of acceleration is known as jerk. If we take derivative, a'(t) equals 6pt plus 2q. Therefore, at t equals 1/2, we have 3p plus 2q equals 0. So we have our third equation. So we have this system of equations, equation 1, equation 2, and equation 3. Here, since the second equation and the third equation both contain 3p plus 2q, we can eliminate both p and q by doing equation 2 minus equation 3, which only leaves r equals 0. Then equation 1 becomes p plus q equals 1. And let's call this equation 4. Now, from the third equation, we have q equals minus 3 over 2p. And if we substitute q with this expression in equation 4, we have p minus 3 over 2p equals 1, which gives p equals minus 2. And from here, q equals 3. So we have obtained the values of p, q, and r. So the velocity vt between 0 and 1 is given as minus 2t cubed plus 3t squared. So the acceleration in this interval is given as the derivative of vt, which is minus 6t squared plus 6t. And you can easily convert this into the vertex form, which is minus 6t minus 1/2 squared plus 3 over 2. So it is a parabola with a vertex 1/2, 3 over 2. Note that it also passes 0, 0 and 1, 0. For t greater than or equal to 1 and less than 2, vt is constant, so acceleration at is 0. For t greater than 2 and less than 3, since vt is a straight line with negative slope minus 1, at is simply minus 1. Now what about this point, t equals 2? Well, since vt is not differentiable at t equals 2, at is undefined at t equals 2. Therefore, combining these, the graph of at looks as follows. Parabola here, 0 here, undefined at t equals 2, and negative 1 here. And that was all for today's video. Thank you all for watching, and please hit that like and subscribe buttons, and I will see you in another video.